Hello everyone, I, Akash Nath, welcome you to the ELP101 project. In this project, I am going to discuss the op-amp adder circuit. Now, what is an op-amp? Operational amplifiers, also known as op-amp, basically has voltage comparator inside it, which has two inputs. One is inverting input and second one is non-inverting input. When voltage at non-inverting input, that is the positive end, is higher than the voltage at inverting input, that is the negative end, then the output of the comparator is high. And if the voltage of the inverting input, that is the negative end, is higher than the non-inverting input, that is the positive end, then the output is low. Op amps have large gain and usually used as voltage amplifier. Op amp, that is the operational amplifiers, has so many interesting applications. We are going to study one of the applications of op amp, which is to add two or more input voltages, and the circuit is called summing amplifier or op amp adder. Now coming to the components of the summing amplifier or op amp adder, we will have an LM741 operational amplifier, 4 resistors of 1 kilo ohm resistance, and power supply for op amp plus VCC and minus VCC to be 9 volt DC supply, two input voltage sources, but there is a condition that the sum of the voltages should be less than the supply voltage. This is the necessary condition for the op amp to be working, and a digital multimeter for testing. Now coming to the circuit diagram. In this diagram, this is the op amp. In the op amp, this end is the non-inverting end and this end is the inverting end. The non-inverting end is grounded through this path, and this point A and this point 3 is virtually shorted. This is the one input voltage V1 which produces a current I1 which goes through R1, and this is the second input voltage V2 which creates a current I2 which goes through R2, and this part of the circuit is called as the feedback part. In this, the current is IF which is going through RF, and finally we will get the output as V0. Now coming to the circuit analysis part, if we apply KCL at node A, we will get this mathematical calculations, that we will get I1 plus I2 is equal to IF, and from Ohm's law we can write I1 as V1 minus 0 divided by R1 and I2 as V2 minus 0 divided by R2 and IF as 0 minus V0 divided by RF, and hence we will get V1 divided by R1 plus V2 divided by R2 is equal to negative of V0 divided by RF, and finally we will get V0 is equal to negative of RF into V1 divided by R1 plus RF into V2 divided by R2. If there are n inputs, then we will get V0 as negative of RF into V1 divided by R1 plus RF into V2 divided by R2 plus all the way up to RF into Vn divided by Rn. This is called the scaling of input voltages by op amp. Now let us consider R1, R2 and RF all are equal to R. So the equation will become, for the two inputs, V0 is equal to negative of V1 plus V2, and for n inputs it will be V0 is equal to minus of V1 plus V2 all the way up to Vn for n number of inputs. This is called the unity gain inverting adder. Now uh, there is a negative sign in the RHS. It means The output voltage and the input voltage will have a 180-degree phase difference between them. That is, the output voltage will be an inverted form of the input voltage. And if we come to the next condition, that is R1 is equal to R2 is equal to R but not equals to RF, then we will get V0 is equal to negative of RF by R into V1 plus V2, and for n inputs we'll get V0 is equal to minus of RF by R into V1 plus V2 plus all the way up to Vn. So in op amp adder output, voltage is proportional to the sum of the input voltages. So here we come to an end with our discussion. Thank you very much.